Thank you very much for taking the time today to view our video. Before we begin, we'd like to take a moment to introduce ourselves. There are many aspects to 9.Connects, but it boils down to the fact that we're a PCB Centric organization. We believe and focus on the PCB due to the fact that it is truly the center point of all electronic design. That's where our expertise lies. We provide services not only in the PCB layout, but in design consulting as well. And during the technical portion of this webinar, you will see this expertise in motion. We are now the exclusive North American instructors for Altium Designer. We host 100 trainings throughout the year across North America, and we are excited to bring these trainings closer to you. In addition to our services, we are also a value-added reseller for a number of PCB-related software companies. And just to note, each company has been presented in past webinars. So if you're interested in them, please contact us or check out our website. And by the way, we provide one-on-one coaching for these tools as well. For more information on our services and past webinars, please contact us. Our information is listed in the description below. Thank you for giving us a moment of your time, and please enjoy the presentation.
So if we look at the, I've got several designs created here. And if I go in and we look at this one, this is similar to the one that Paul just showed you. I created this this morning, so I've done probably 80% of it, and it's basically by drag and drop. Now what I want to do first is to talk about the tool itself, because it is not just a cabling tool. There are several aspects to the tool itself, the first being schematics, and any type of schematic. So you can do hydraulics, pneumatics. For example, if I go down and I look at this one, you can see there's a hydraulic schematic and as well as the electrical schematic. So it is a schematic tool. It is also a panel tool. And by that I mean if I open up the control panel drawing, we can see and if we zoom into it, we'll see it a bit more clearly. We can see a control panel layout, and if we look at the logic in here, we can see the logic of the connections coming from the schematic itself. So each of these terminal points is associated with the corresponding schematic symbol on the schematic page. And if we now go in and say auto connect, and I've just selected that specific one, we can see that it is automatically connected. And if we look and hover across a wire, we can see the signal associated with that connection, the size, the color, the length, and any options associated with it. So looking at that wire, it's going from here to here. Now the length, even though the tool is a 2D design tool, it does, as far as the panel components are concerned, it does have 3D information. So it knows the height of that connect point from the base. So now it can calculate, okay, I need to go down to the base back plate. I need to go to the wiring trough. I need to come up to my destination and then come from the back plate up to the height of that connection point. And that's how we can get the true length from the panel, even though as a user, we are working in the 2D mode. So also looking at this, if we look at this, talking about cables, when we zoom into this part of it, we can see for this motor, we have a cable. The motor itself has a pigtail with a connector on it. We can see the connector on that side, and it's connected up to the rest of the circuitry. So this cable itself, if we look at it, there's 4 conductors here, pins 1 through 10. If I jump to the tree, and that's the device tree over here in the project, I can see those pins, but if I click on these connector pins are on a different sheet, and they're actually associated with the protection circuit associated with that. So within a project, I can have my cable, my conductors of my cables and wires spread throughout the schematic itself, which makes it a little bit difficult to actually track them, but because of the functionality provided with cable, I can actually go in and say, well, what I want to do is have another drawing, and in this case, I'll use this cable pan drawing, that shows all of the cables, or the conductors of this cable in this case. So we can see the original 4 conductors, we can see the 2 circuits for the protection, and these 2 are shielded, and this is a complex cable. So that's an additional view to what we've seen in the schematic itself. And also I can have manufacturing views, and if I hover across, you can see the information about the conductors within this view itself. And then I can have a tabular view. And the tabular view is just telling me what the pin connections are. Now, normally this would be on different drawing sheets, but for the sake of this presentation and this example project, everything's on one sheet just so that you can see it. And I will go through and show you this functionality later on in this presentation. Now, a quick description of the tool. It is Windows-based, as you can see, just like you would find anywhere else in Word or Excel, similar commands. A lot of drop-downs, but most of the time you don't have to worry about the drop-downs because you can right-click on anything and the associated commands will appear in the pop-up menu. There is online help, and then if I look at the contents of that, everything is in there that you could possibly want to see. I'm not going to spend any time on it other than to talk about the interface. The API, for example, for the tool is standard Windows COM, so you can actually get at any of the data within the project itself, and so you can access all of the data in the project and generate output from that, whether it's a connection list, a wire list, or anything. So all of that data is available, so you can generate output, whether it's for a cut, mark, and strip machine, whether it's to go to an ERP system, or anything like that. You can generate output because all of that data is available to you. Now, just talking a little bit about these toolbars, underneath we've got different sets of toolbars. I'm not going to spend time on the toolbars, but this is the connection toolbar, for example. This is the control panel toolbar, so you can see different commands within these. This is the form board toolbar, and I'll spend a little bit of time on the form board. And by the way, this toolbar itself, I'm not logged in, but this is for Team Center. We have different toolbars and different connections to PDM systems. So if it's SolidWorks, Enterprise PDM, or Windchill, or Team Center, or Smart Team, we do have interfaces to those. And for the user, it's just a matter of using these, the toolbars specific to that PDM integration. If we look on this right-hand side, everything is a window, so we follow everything that Microsoft tells us. So everything is a window. You can put these windows any way you wish. I'm using a laptop because I travel a lot, so I leave my screen size is not great, but normally you would stack these up so that you've got more of this blue area, which is the working area. And if you have multiple monitors, you could put these other windows onto other screens. So now, looking at this library, by default it's in Access format because it's on single user, it's on my laptop, but it could be SQL, it could be Oracle, and it would typically sit in a central server that everybody's using. The library itself split into several sections. Symbols be the first one. If I click on any symbol, there's a battery symbol popping up. Symbols exist once, and they're used many times for different components. So however many battery types, for example. And pin terminals that you'll see me use, the pin terminal is one symbol used many times. Components, in the Components tab, can use one symbol or many symbols. This is a relay symbol, and we can see all of the different symbols appearing up here. And depending on the symbol itself, I could also have a corresponding panel symbol, and once placed in the panel, it will show a lot more information, because the panel symbol, like all of the other symbols, if we look at this symbol itself, it's just the graphics appearing on a sheet. You can't see the intelligence, so you can't see the connect points. You can't see all the text nodes that will display information when there's information to display. So it could be the terminal number, it could be the part number, the device ID, and so on. So in addition to the symbols that are used by a component, we also have attribute data. And there's no restriction on the amount of attribute data you can have associated with any component. You've got the freedom to describe the attributes and to have the attribute information associated with the components. And in the final tab in this library, we have different types of symbols that don't directly relate to a component itself. So, for example, I could have sheets, drawing sheets. You'll see I've got many different types of drawing sheets in here. It's just a symbol that we add intelligence to. Attribute text templates, you'll see these used. Basically, when you drop these onto the connection, it will interrogate the connection and display the information associated with that connection. So if there's nothing to display, it won't display it. But for example, it could be gauge, it could be color, it could be wire number, wire name. Whatever it is that I want, I can have that attribute associated with it. And we've got other symbols like shield symbols, because we deal with shields in the makeup of a cable. So that is that aspect of it. And then we've got other, as far as this project window is concerned, this is this window in the top left-hand side. What you can see here are multiple drawing sheets that I'm turning on and off, including the panel sheet that we looked at, including the cable plan that we looked at, and so on. But in addition to that, there are other documentation included within the project. In this case, PDF documents, Word documents, Excel, any type of file that you want to include in the project. Now, the project itself is just one file. So that gives you several benefits, the first of which is for vaulting and storage and so on, and tracking, it's easy. It's one file, and it includes all of this information. Another advantage is that all of this data, so as I bring things in to the project, it resides in the project. So it's not looking for information from this library. So if I open this up in 5 years' time, for example, and this library's completely changed, it doesn't matter. This is as it was designed, and all the information is in that. The third advantage to this is that I can open this up in the Viewer tool, which is free of charge, and you can put it on anybody's laptop. And I can go through it, I can interrogate it, I can do searches, I can go in and look for things, create, I can outputs, I can generate prints, plots, and so on, and I can jump around just as you can see me when I start to show you things. The only thing I can't do is change it in the Viewer tool. So this window is not there. You don't see that one. So that's a quick overview, and just to recap, what we can do is we can have schematics, and it's one tool. I should point out it's one tool, and licensing opens up functionality. So we have the ability to create a schematic, all of the interconnections and so on. We can do control panels designs. We can do the cabling views. These are the different views of the interconnections. And we can have form board creation. And the difference between this type of definition and a form board is that it is actually created to real world dimensions, as opposed to me drawing it and giving it a length. So you could actually plot out a form board sheet onto plywood and actually use that as the base for building a cable, harness, and so on. Other important things is that we deal in objects. And by that, I mean that if I look at this relay and I just drag it on, let me look for the schematic sheet, and I drag it onto the sheet, And so I've dragged on this normally open contact. When I go and look at it in the device tree, so I'll jump to the device tree over here, I can see that I've got the complete object. So I've got the coil, I've got the normally closed contacts, and normally open contacts. This means that I can't overuse contacts because it is exactly as built in the library, so it prevents errors and it's tracking it. And it doesn't matter where any of these pieces are or these symbols are on any sheet. Whenever I make a change, that change will reflect everywhere. Other parts of the project tree that I didn't mention were the panel parts. We can see the parts that have not been placed in the panel and the parts that have been placed, and we deal with variants and options. And quickly looking at this sheet, what I could do is to say, if I do an overview of that sheet, if I turn off the associated options, I can leave it grayed out if I wish, or I can make it disappear off the sheet as I've got it set in this case, so that when I generate output, whether it's a plot or a bill of material or a connection list, depending on whether it's turned on or off, it will either appear on the drawing sheet and in the bill of material and the connection list, or not, depending on the settings. So that's a quick look at the tool itself. So now let's go, and I'm going to close this one, and we'll look at the project that was created before. Now, if we look at this one, I created this one this morning. These are real objects. So I can look at this, I can say, okay, let me look at that by jumping at the tree, so I can see every pin that's used. They're in blue, and it gives me a location as to where they are, and I can see the pins that aren't used because they're in yellow and there's no location information. I can also look at additional views. So if I see this, and you can see the preview popping up of that, if I go and jump to that view, I can see the view of it there. So what I want to do now is to spend a little bit of time and explain what is the functionality of the tool and what cabling gives you over and above the schematic. So I'm just going to focus on the functionality of cable itself, and then we'll come back and look at this example that Paul created before, and I'll show you some. I'll create a little bit more of that from another example that I have. So, and this is the one that I will use later on and just complete it so you can see it. But let's talk about the base functionality to start off with. If I look at this simple D-sub, and I'm using a 9-pin D-sub because I don't want to use something that's got 125 pins and trying to fit it on the sheet. This will be fine. So if I just drag this on and look at it, this is a female representation, female pin. If I make a connection to that, you can see what the male representation would be. Now, that is an international standard. It could be an arrowhead, could be anything. It's just symbology. It's the functionality that counts. What I could have also done, now if I take this and jump to the tree, and by that I mean jump to the device tree, what I can see is this icon at this location represents every single pin. Okay. I can also go in and say, well, place every pin. Now for this instance here, you'll see the star 9 that indicates it's every pin of that connector. But in this case, I've got every pin with an individual symbol, and we can see that over in the tree. So each of these pins, if I click on them, they will highlight. It's in blue, it has its own location, and I could move it anywhere I wanted to. And it could be on another sheet, for example. So if I was to go in and say, okay, let's add a sheet to this project, and then I'll take this drawing or this pin and put it on that new sheet. So I'm just dragging, dropping it. And now if I jump to the tree, you can see that that's on sheet 3 as opposed to the sheet 2 of the others. Going back to this representation, if we now go and look at the same connector, and I'll say, okay, I'm only going to use these pins. So I can drag these on. Now if I jump to the tree, you can see the pins that are used, the pins that are available. Because it's an object, as I brought it in, I brought all of the parts of this specific connector into the project itself. So I know how many terminal pins I've got within this connector, and I can see the ones that are used and not used. If we also look, we can have different representations. So that's one type. This is another type. If I go in and say, okay, if I drag this one on, that's the equivalent of this representation. So doing the same thing again, if I go in and say, well, I want every pin, I get a different representation. This is a standard used more for military applications. Probably 50% of our customers use this type of representation. And again, if I go in and say, well, I only want to use these pins, notice how the representation changes, because it's saying that this representation does not contain all the pins, and the display is controlled by this toolbar up here. So now let's take that, and I'll use the same example, but let's take that and show the functionality of the cable. Now I'm going to do this all on one sheet, and I'm going to make it simple, but it's going to show you functionality. So I'll go in and say, okay, I'm going to do an interconnect level diagram. And so it's just connectors to connectors. In this case, I'm only going to use two, and I'm going to make that connection. If I hover across it, you will see that there are no conductors in there. Now, if I go in and say, okay, I want a new device view, and I want to show every pin, okay? So now I want to say every pin of that connector. Now this extension #1 is something I can turn on or off, and that's just as a guide to say this is another view of something that's already in the project. So now I can go to this side and say place new device view for this one, and we'll flip it so the mating sides are together, and I'll just connect these up. Again, I've not assigned any cable or wire, but I could have by picking the default wire up here. But I want to show you how all of these views are linked together. Again, I could have something more like a manufacturing view. So I'm going to say, okay, let me place this view, and I want it to look like, and notice how this has got many different types of symbols associated with it. So I'm going to make it more like the real thing, place that one down, and same for this one. Now, often this is going to be it will be many connectors because it's a harness. There could be different types of connectors. I'm just trying to do this, keep this simple for the time that we have available. So again, nothing within this. And then let's say I want to see the tabular view. And this helps in manufacturing purposes. I've got several tables here, but I'm going to stick with this one. And I'll say place that. And this is the table associated with this specific connector. Now, let's go in and say we'll put a cable on that. So what I want is a control cable that has enough conductors. So I've already opened this so I don't have to search for it. So this has a 9-conductor cable, and I can go in and say, okay, let's connect those conductors. And then I can go in. Those conductors are connected. Now, if we look at this and I hover across it, I can see the conductors are now associated with this connection, and also the table is now complete. And the table is showing signals. And we'll look at signals a little bit more in a second, but the signal is part of the definition of a connection. So now I could go in, for example, if I wanted to make this more lifelike, I could go into the connection properties and say, okay, let's make this a little bit more like it, and let's put in a dimension associated with it, and so on. So there's my dimension. This is associated with the paper. So as I move it, it changes. But what I could do is to go in and say, well, in the properties, I just want to put a value in there. And I could have got that value from any source, and we'll talk about that later. But now when I change it, nothing happens to that. I could also go into this and say, well, what I want is to, I want cable protection associated with it, and I can stretch that to suit, and so on. And this becomes part information associated with all of this. So those are some of the things I can do. I can also have documentation graphics, and documentation graphic can be anything, but in this case I've just got the pin layout. It could be an isometric view, it could be photographs, it could be anything that you want by way of documentation graphics. So that's a quick look at the functionality of cable, and the thing about it is this is another view of that, this is another view of that, and this is another view of this particular connector because it's just showing the connections to that side. So that's part of it. Now let's look at blocks, okay? And I'm going to go in and say I'm going to place a block, and this block can represent anything. So in this case, what I'm going to do is I'm going to put in a receptacle, and I'm going to say place the receptacle on here. Now whether it's placed on the inside or outside is controlled by these buttons. And so I'll place another one. And these blocks, by the way, can be stored in the library. If you use a block for some specific component, you can store them. If you look at this one, this has got PCB information associated with it already. Now the block itself represents any device. It could be a commercial, a purchase device, for example, where you typically don't care what's in the inside or don't know what's in the inside, but you know what connectors are on it. So it could be, in the case of an LRU, it could be many connectors with many, many pins on each connector. So if we now connect this up, and I'll just make the connection, there's a connection. Now notice if we zoom into this, we can see several things. First of all, it's put the mating connector in that because it knows the mating connector. Also, the signal is transferred through. So we deal with signal transfers, whereas, for example, a wire would go from A to B, a signal would go from A to Z, depending on how many interconnections it goes through. So if we look at this, and we look at the device properties, and we look at the signal on the pin, on that specific pin, and I'll just change that, and I'm just going to put my name in this, just to give it a name, just to give it a signal name, and say okay. Now notice how that transfers across, and we can see the signal associated with the wire. Now if I go into this and say okay, what I want to do is I'm going to put in a receptacle and plug, and I'm going to say okay, place the single pins. Now notice it puts its mate in there, so now we've got a breakpoint. So I'm going to unplug this pin, just the one pin of this specific connector. That's an intermediate connection between these two. And now if we look at the device properties of this, go into the device properties here, and I'll say that this one, again, just putting any name in, and so now I'm going to say there's my names. Notice how Fred transferred through, because it does transfer, but the Joe didn't because it's not connected. And when I do connect it, it now flows through. So signals go all the way through, wires just go from A to B. Okay, now let's look at, I'm just finding space on my drawing sheet. And what I'm going to do now is just to say, okay, just to show you some more functionality. And I'm showing you pieces of functionality as opposed to making it too complex, because all of this functionality adds up to create the design. So now we'll place this one, and what I'm going to do in this instance is I'm only going to connect up to 2 pins of each connector. And what I'm going to do is to connect these with a shielded cable. So if I look here, I want a shielded twisted pair. So there's a shielded twisted pair, and I'm going to connect this. And so there's my connection made. And by the way, if we look at this, I'll just close this 1 second. What we can see is that's the original cable, and this is this cable. I think it's this one. So there's the shield, there's the twist, and there's the conductors of that connection. By the way, this is an attribute text template. It's my default one that I've got set to display just the conductor of the cable. Now if I go into this and say place the bundles, now it's automatically placed my shield symbol and my twist symbol. Remember, the symbols can look like anything. So this could have been the Z-type shape or the arrowhead shape, depending on requirements. This could have been a dashed line instead of a solid line. It's now placed them, and they are associated with that specific connection. Now, if we notice, if I make a connection to this, and I'm going to make a connection to this, and say to pin 9, what the software is doing is it's tracking the shield connections. So if I go in and say, give me a report of the connections, what we'll see is, if I got it on the right screen, we'll see that P22 is, the shield is connected to 9, and on P21 it's 6, which we can see from that. So that is coming directly. We can see the information on the wire and so on. And we'll look at the output from the other one. So that's a little bit more functionality. Now what I want to do is to show you again, if I've got space over here, to show you a little bit more of the functionality of the tool as far as wiring and harnesses is concerned. And in this case, what I want to do is to say, okay, I want to go in. This specific one is, I think it's 37 pins. I don't want to use all 37 pins. I just want to use several pins. And so there are the pins, terminal pins of these connectors. And if I go and jump to the tree just to show, I can see all of the rest of the pins ready for placement. But I only want to show you some functionality. So again, I'll connect these up. I haven't put a wire or a cable in there yet, but let's look at the device properties. If we look at the device properties of this, what we can see if we look at the pins, first of all, we know what the mating part is because it's telling us that. Now, if we look at the actual terminal pins associated with each location, we can see that there are 2 associated with these locations. One is a 2420 gauge and one is a 2824 gauge. The default is set to the 2420 gauge. So now, if I was to look at this and say, okay, what I want to do is to place a wire on that. So there's my wire, and if I said, okay, I want to place an 18 gauge, notice how I get an error because the 18 gauge doesn't match the size of the pin. Same thing is true for the 30 gauge. So it's telling me that won't work. But however, we do have a pin that will work with the 20, and we do have a pin that will work with the 28. So this time, if I look at my device properties, I can see now, if I look at the pin 1 is the default, but if I go to terminal pin 2, it has changed to the alternate one that was assigned to that specific location. And things to note is in the more complex connectors, I can have different terminal pins associated to any location, and that includes quadrax and coax pins. Now, so just a quick explanation of that. When I drag a wire onto a connection, it will say in its interrogation, does that wire match the size of the terminal pin? If it does, allow the connection. If it doesn't, is there a terminal pin that has a wire size that matches that wire? And so if it does, it'll say switch to that terminal pin. And then it'll say if it doesn't, then it won't allow the connection. So that's the functionality that's taking place there. So we can see we've got additional functionality throughout the tool. Now, I know I'm going a little bit over time, so let's go in and look at this one, and I'll show you how it's on sheet 1, how I created this drawing just to show you some of the functionality. So now if we zoom into this area, you can see that we've got a attribute text template. This one is telling me which wire of this cable. This one tells me the cable and the wire. This one is the signal name, and I've got connections to it. But if I go in and say, okay, I want to make this connection here. All I have to do is to go in and say, well, connect those. So now what I've got is the connection. I've got the mating parts. Now this is part of the main part of this one. It's just the ones that are available that match up with these parts existing on this, or the pins of the connector that exist on this block. Now if we go in and say, okay, we want a cable, and let's look for, let me close this 1 second, and we'll look for, I don't see them in this view, probably because I need to update my library because I just created it this morning. And so this one, alpha wire. So now we've got a cable in here, a shielded cable. We can see the different conductors. So now if I go in and say connect conductors, I can go in and say, okay, let's connect those conductors. And so now we can see the connection information. If I hover across this, I can look at the connection properties. I can look at the cable. I can see what the connection is. I can see what is pin 1 of P3B. I can look at is connected to P1B, pin 1. I can see the wires individually connected and so on. And if I go over to the W5 in the device tree, I can see the cable itself. So there's W5, and there's the shield not placed, but I can go in there. I could automatically place it as you saw me before. I could go in like so and just make the connection. And then say, okay, where is this connected to? I'm not sure, so I'm going to leave it open-ended for now, but that's the type of functionality, and that's how quickly I can do it. Now, if I want to go in and say, okay, I want to see the rest of the view that we saw in Paul's example, what we could do is to say, well, let's overview this one and say, okay, I want to place a new device view. And in this case, I want it to look more like the real thing. So there we go. I'll place that one. And same for this one over here. And so now I'll say place new device view of that. And again, I'll flip that around. And we'll make the connections for that. So there's the connection. If I hover across it, we can see all of the conductors that are in there. We can actually go in, if we zoom in a little bit more to this, we could go in and say, okay, what I want is the Tyco connector is the one that I used. And I'll explain this in a second, but what I'm going to do is just put the back shell in there. So there's the back shell as shown in Paul's. Now this is a component in its own right. I could put it, I could make it part of the connector by default. So, and then other things I can do is say place a new documentation graphic. So there's the documentation graphic for that. If we look, we zoom in, it's the details, it's the pin layout of that particular one. And then I could start by going in and adding additional information to that. So that's my process. Everything is drag and drop. If we'll notice here, we've got the specific connectors. We've got the back shell associated with it. So there's the back shell with its symbol that we can see popping up in the preview. What you can see also here in red are contact pins associated with these connectors. They're red because there's no symbol associated with them, because it's just the standard symbol that's used, but there's no true graphic representation of that, although I could have one. So now if I go back to the original that is complete, this is the same drawing that I've completed, and we look at the information associated with this. I could go in and say, well, give me a bill of material from this project, and there it's created the bill of material on the fly, and you'll notice it's item number quantities. So there's my two back shells that I've added with I've got device IDs of back shell 1 and back shell 2. I could have associated with them with the plugs themselves and given the same definition. There's my cable. Again, it is quantity. and the terminal pins. Notice how these are the terminal pins associated with the block itself. Because I have them as components, I could have just had them as part of the definition of the block and they wouldn't show up. But these are the used contacts, and so the quantity is different. And then we've got the different items that we've got below. So these are the terminal pins, these are the connectors themselves, these are the cables and the back shells, and so on. That automatically comes out of that. If we look, we could also go in and say, well, give me a, from that, give me a connection list. And so there's a connection list generated, and we can see the signals associated with that. We can see from device pin to device pin, and we see the pins that aren't connected, and we can see the ones that are connected with the conductor name of that specific type of cable, the actual color, and this is a strange cable because the conductors are named black 1, black 2, and so on, and engage, and then the name of the cable itself. And if we go, we can also, as another example, say, give me a cable list. So there's the cable list. So now it says there's the cable, there's the device, and it's telling me what what's connected to what via the conductors within this report. Now, if I got length associated with it, it would sum up the length of all the segments that it went through and give me that length information right there. Now, let's look at the scenario of where I got the length from. In this case, I've just put in a length into my example here. But what I could do is, as far as the tool's concerned, I can develop all of my interconnections. I can define the harness with all of the components of the harness, the back shells, the terminal pins, any labeling, any type of cable protection that I want. The thing that I really don't know, other than by putting it in manually, is the length information. So what we do is we go in and we can interface to mechanical tools, any mechanical tool. So what this does, this 3D, we call it the 3D bridge because it is a bridge to the 3D world. So what it does, it interrogates the project for every single cable wire within that project. And you can select it based on how you've defined it, whether you've got a harness assembly, something you picked on the screen, or attributes, or a harness. Depends on your definition. And then you can go to any type of mechanical tool depending on which one that you're using. So I don't have, as I mentioned, this is a laptop and I don't have NX and SolidWorks and Solid Edge and so on this laptop, but a quick explanation of what happens is that depending on the tool, if you'll notice, if I pick another one, all of this changes based on the requirements of the specific mechanical tool. So it will extract the data from the project and generate an output file, typically an XML format, that can be imported into the routing module of the mechanical tool. So in this case, I have got just two connectors and the wires and cables between them. So what I could do now is I can open up that file in the mechanical tool, and so then I can go, when it sees in the listing I've got two connectors, it will say, okay, pick the first one, and the first action it does, because the information is there, is to go and get the solid representation of that particular connector. So then you would place it inside the model of the machine or whatever it happens to be, and once that's done, it'll say, okay, the second connector, it'll go and pick the model associated with that, and so on until all connectors are placed. Then it looks at the rest of the information and it highlights connections. And these are just rough estimates of the route it would take. So now you can adjust this highlighted line around the model to say, okay, this looks like the best route for me to take. You can adjust or move the merge points if it's a real harness with many connectors hanging off that harness. So you can move those merge points. Once you're happy with it, it will look at the rest of the data and it will fatten up all the segments corresponding to the real diameter. So then you can see If it really fits, you can make more adjustments if you violated bend radiuses and so on. Then you can say, okay, now I'm happy with it. And at that point, it knows the length information, and you can import the length information. And it is actually the same file, because when we send it over, there's a length field, but it's empty. So then you can bring that length information back into here. And the other thing I didn't show you before is we can look at segment information. We can see what's in each of these segments. You see the OD, the makeup, and so on. And that's what the mechanical tool is using for routing purposes. So once you're happy with the route, we can get the length information back here.